Hi.
Hi.
Please introduce yourself.
Yes. So nice to meet you. I am Steven Bardet, co-founder and CTO of Aerleum.
And you do e-fuels out of air?
Yeah, definitely. Aerleum is doing e-fuels out of air. So we are a French startup, and we have developed innovative process that combine the CO2 capture and its conversion.
And so you do CO2 capture, but you turn it into energy for...
Yeah, exactly. We turn it into methanol, so that's the first fuel we are targeting. But we do carbon capture, but in a different way. We like to call it reactive carbon capture because we have invented a dual functional material which have the ability both to catch the CO2 at its surface, but also to convert it directly into different kind of fuels. So by doing that, we just slash down some of the most energy-intensive steps in the CCU value chain.
That sounds amazing if it works. Does it work?
Yeah, it works at least in our lab. So right now we are able to make liters of fuels per month in our lab. So that's still small scale. But last year, end of last year, so end of 2023, we just raised $6 million to build our bigger prototype that will be able to produce 30 tons of fuels per year out of CO2 in the air.
Did you say you raised $6 billion?
$6 million, yeah.
Million, yeah.
Yeah.
Billion next meeting, right?
Yeah, maybe. I hope so.
So with those 6 million, what you can demonstrate exactly?
So this 6 million will allow us in the next 18 months to build what we call our pre-industrial module. So this module will be able to produce 30 tons of methanol per year. And that will represent, let's say, the kickstart of the industrialization of the Aerleum technology.
So what's important is to make e-fuels cheaper than all other ideas in the world.
Exactly.
How is that possible? Can you make something that's the cheapest e-fuel?
Exactly.
The cheapest fuel. You can do it?
That's the goal of Aerleum. So by combining the capture and the conversion in one single reactor with one single materials, we save 30% of energy compared to like competitive processes.
What do I see here on the screen?
Yeah, so here what you can see is our reactor. So this is where we put our material. So inside this reactor we have our bifunctional material. With low air, the CO2 is fixed into our materials. And once we have saturated our material, we just add hydrogen to combine the CO2 with the hydrogen and make the e-fuel. And
so you add hydrogen to carbon.
Yeah, exactly. Yeah? We combine the two molecules with a catalyst, a specific catalyst, and we can do this methanol. And why?
Is that the same strategy to make the fuel on Mars?
The fuel on Mars, yeah, exactly.
Is it the same process?
Yeah, not the same process, but the same strategy, like using the carbon dioxide with the hydrogen that is made out of water, so water electrolysis, and then combine them with a catalyst and making fuels.
There's one problem: to get the hydrogen out of the water, it takes a lot of energy, no?
That's one of the biggest problems right now, but that's also the beauty of our technology. Because we deal with the CO2 in the air, we can locate the technology anywhere in the world, and for us, anywhere in the world means where electricity and hydrogen is cheap.
So maybe, for example, Denmark has a lot of windmills. They'll do a bunch of hydrogen, and then the US is so dirty, polluting, or China or something, and you combine those together and you get fuel.
Exactly. And with our technology, we have the fastest timeline to price parity with fossil fuel. So we target in the next 5 years to be at $500 per ton for our methanol, which is the current price of fossil methanol.
Okay, so let's see the next slide. Do you have another you can show there? Yeah. Let's see the next. Oh, there. Yeah. Oh, there. What do we see? Nice. Yeah. So this is the logo.
Aerleum. That comes from petroleum. But instead of taking the carbon from petrol, so the earth, we take it from the air.
Nice. And then the next slide is going to be. Maybe you go there. Yeah.
Sorry about that.
It's a MacBook Aerleum.
Just go ahead.
And so we make e-fuels out of air.
Yeah.
And then then you say maritime, aviation,
Exactly.
chemicals.
Methanol is used in maritime transport, so it's seen as a decarbonization vector for shipping industry. So
Yeah.
they can just put methanol into boats and power the boat with methanol. For aviation, methanol is a building block to make sustainable aviation fuel. So make greener aviation, and it's also a big building block for the
Is that
chemical
better?
industry.
Your solution is better than just running the airplane off hydrogen directly?
I mean, that depends. I would say yes, because our fuel is liquid, so it's better to store. If tomorrow you need to store hydrogen into a plane, you will be limited in terms of quantity, and then you will be limited in terms of distance for your trip.
There is one problem. Every time you do a process, you lose some, what do you call it, efficiency or not?
Yeah, so that's also the beauty of our technology, because we combine the capture and the conversion steps. We have a process efficiency of 52% compared to like competitive process that are around 40%.
All right. And it says the fastest timeline in the market to match fossil fuel price.
Exactly.
For sure.
For
You're
sure.
gonna get cheaper than Russian oil.
Don't know, but
Or
for
cheaper than
for
Russian
sure
gas.
we're gonna be at equilibrium with the current price of methanol. So the current price of methanol is around $500 per ton of methanol, and that's a fossil methanol, and we're gonna do a green methanol, so a low carbon methanol at the same price.
How soon?
Soon?
How soon?
In the next 5 to 6 years.
5-6 years.
Yeah.
All right.
Because we need now to scale up the technology.
Fuel anywhere. So anywhere, for example, there's wind or solar to convert water into hydrogen.
Yeah.
And where there's a lot of CO2 emissions somewhere nearby.
As we take the CO2 directly in the air, we don't need to be like at an emission location, so we can just deal with the CO2 anywhere in the world. So that's why we can produce e-fuel anywhere.
Nice. So
We
it's
just
got
need
nothing to do with taking the CO2 out of a city or something like that.
Sorry?
It's not about taking the CO2 pollution out of the air.
No.
Not necessarily.
No, it's not about taking the CO2 out of a fume, for example, like a
car.
natural gas plant or something like this. We are really taking the CO2 which is in the air.
Wow. It sounds like a holy grail kind of project you have going on. What do people say? Like top scientists, what did it tell you?
For now, they are really like support us because that's, as you say, that's the holy grail of doing fuels for the future. Because what we are building is really like a circular economy around CO2. So we take a molecule of CO2 from the atmosphere, we make a fuel, we burn this fuel, and we release the CO2 in the atmosphere. So we have a neutral cycle. So that's definitely what we're going to do.